Tarcisio. I am Davide Lanti. As you know, we work together in INODE, researcher at the Free University of Bolzano, and today we are going to show with my colleague Tarcisio the service of integrated query processing of INODE. My research interest is in ontologies and knowledge bases and all that. And can you present yourself, Tarcisio, as well?
Yes, of course. Then I'm Tarcisio. I'm working at the Swiss Institute of Bioinformatics as a computational biologist and research scientist. Mm-hmm. And to let you know, actually, currently we are working in collaboration with the OncoMX database developers. That's a database about the cancer biomarkers and related data.
So Tarcisio, could you tell us more about this use case? Maybe you can share your screen.
Yeah. Yes, of course. Then essentially we had like a user that he's a cancer biomarker researcher. He was looking for repurposing existing food and drug administration approved biomarkers to other cancer types, and to further see if other genes may be good biomarker candidates actually. Mm-hmm. Then he had the following question first. It was to know, okay, what are the top 20 genes expressed in some cancer in the respiratory system? Then to do that, we currently with the OncoMX web portal, for example, it's not straightforward as I'm going to show you now. Okay. For example, in this case, to answer the first question, to go to differential expression data set here. Afterwards, he would have to select which cancer types are in the could be considered a respiratory system cancer type. Then in this list, we can see that we are lucky that actually we only have one cancer type that belongs to the respiratory system. This is the lung cancer. And then we would have, because otherwise if you have others, you would have to check one by one. Then we will actually also order by the increasing of expression levels. To do that, we could select this fold change column here.
Yeah, this top 20. Yeah, okay.
Yeah, and click twice. Then we're gonna have the decreasing order. Then essentially now, with this information, this cancer biomarker researcher, he wants to know which of those genes actually is also considered an FDA approved biomarker actually. Then for doing that, he had to go actually to the data set about FDA biomarker here.
So you need to join, okay.
Yeah, I would have to join like the intersection between the two results. And essentially this, he has to click again to go to the FDA biomarker. Then once there, he would have to go, actually he had to actually copy and paste each gene type here in the search field.
Yeah.
And you're gonna check actually.
Yeah, whether it occurs or not. Okay.
This is not there, and after checking all training, you see that the 19th actually, the KRT14, it is considered cancer biomarker, but for breast cancer.
Breast cancer, okay.
And also furthermore, it's approved. The approved indication for prognosis. That then it's worth investigating that probably this gene could also be a good candidate for a cancer biomarker for prognosis, but more specifically for lung cancer. Okay. And essentially after that, he could also check. It also offer more investigation about the other genes that has a high expression. That
but they are not approved. Yeah.
Yeah, they are not approved, but it's worth investigating if they are actually a good candidate for lung cancer biomarker, actually.
Okay, so I see that here the problem is essentially, yeah, joining these two different results, and also the fact that if you had more types of respiratory system cancers, then you would have to repeat not only for each single result, but also for each single query.
Exactly. At some point, probably we're gonna have more data, and then you also include all the cancer types in the respiratory system. Then the user would have to go do the same steps that we did more times, actually. Then essentially, if you go here, like in the disease ontology, you can see that all those different cancer types here, and one of them, lung cancer, are considered a respiratory system cancer.
So yeah, so potentially a lot of manual interaction.
Exactly.
Okay, so I show you what we did with INODE. So how we will do this in INODE? So essentially, this is the integrated query processing service, and this service works with a query language, which is SparkQL. On top of it, you could also plug, for instance, natural language interface like those that are shown in other videos of this series. But here we go with the Sparkle interface as is. So what I would do for your query is, since we already collected some information that looks similar to what your problem, what you just showed right now. So for instance, here I have a query that asks for the top 10 genes expressed in lung cancer, right? And essentially we could take this query here and modify it a bit. Now, of course, if you want to do this manually, you need to understand a bit the language, but here it's very simple. So essentially, we just ask for the first 20 results. And rather than lung cancer, and this is the nice part, we can directly ask for respiratory system cancer, right? Because we have an ontology that is essentially capturing the hierarchy you showed me before, right? So we have that lung cancer is one of the types of respiratory system cancer. So in the future, we add more data. We do not have to write different queries, but we can just ask for the superclass. And this comes from the reasoning service that runs underlying this system. Then we have another query here, which is the one that retrieves FDA cancer biomarkers that we can just simply join with the other one. So we can do something like this. So we take this, and here we take this other query like this. We do a SparkQL join, which is, now don't bother much about the syntax. Here we need just the gene label, I would say, right? And yeah, maybe select distinct, and we should be good to go. If yeah, here not the actual use, but we will want to approve the indication, right?
Okay, yes,
and
perfect.
yes, there was a mistake. And well, let's see now if I didn't do things, and if I copy and paste in the correct way, we should get our result, which is in fact
nice.
just showed, right? So we see that in fact this was approved for breast cancer, and we have the approved indication term, which is as you said, the prognosis. Now you see here we have the direct link to the source of this information, and yeah, with also a description of what prognosis.
The definition, yeah, exactly.
So
Sounds great.
yeah, so what do you think? Might be useful for the...
Yeah, I can see already, like, the fact, even because as a computational biologist, I can see that we can take advantage of this service to provide better tools, better user interfaces, actually, that will not require like the user to click several times and try to do several manual things and fastidious manual tasks. Then I think it's quite a good opportunity, actually.
Yeah.
Okay, thanks.
Thank you, Tarcisio.